need to say. Okay, so here is episode 4 of the wireless power series. I've got some new solar panels and it solved all the issues. We are now 100% working capacity. It's amazing, life's good. That's what I want to say. In reality, I got the upgraded multimeters like I said I was going to do, but upon getting the upgrade I realised something slightly embarrassing. That embarrassing thing is I was misreading the multimeters. If you'll remember, I don't know, this moment where I said we were outputting like 67 microamps, in reality we were only actually outputting 6.7. So if it was bad enough before, it's like laughable right now. So that's great. But then I also read somewhere that if you hook up solar panels in series, you increase the voltage but the current stays the same, but if you hook them up in parallel, the current increases and the voltage stays the same. So naturally I thought I would try this out. Right, so I've just set up the solar cells in parallel as opposed to all in series. So now it is 2 separate cells instead of 1 continuous cell, and these are the readings for ambient light. I won't know if anything's changed until I introduce laser light, which I'm about to do now. Okay, that is roughly 55 to 60% of the panel covered in laser light, and yep, the values have halved. I'll introduce 100%, but I think continuous series is definitely the way to go. That is 100% laser light. I'm expecting it to be somewhere between 22 and 27 volts and 2.2 and 2.7 microamps. So evidently that didn't really work, so I then decided, so instead of making it 2 separate cells, I decided to make it 8 separate cells by making the whole array parallel. So I did that. Alright, so I set up all the cells in parallel. Now I'm going to initialize the laser. .5% coverage. Oh yes, that is a suicidal result. There we are, 100% covered, more or less. I don't know what the results look like. That's great. And yeah, that didn't work. So that was kind of disheartening, but then I made a slight discovery. And that discovery was, if you put a transparent medium in front of the solar cells that has a slight tint to it. For example, mine happened to be luminous yellow. Now what happens is the laser light goes in, and because it is a luminous colour, it refracts it and it's really bright. I can't remember why I did it. I think I was just playing about with stuff, just looking for random stuff to like either expand the laser light or narrow it down, but I accidentally made the discovery and these are the results. Right, so I'm now going to try suspending a different coloured medium in front of the solar cells in order to increase the luminosity of the incoming light. So that is, we're just doing it on one now just to do a baseline. The readings for this are approximately 4.12 volts output along with 0.4 microamps. I'm now going to suspend the medium and thingy back the results. Now, as you can see, it's noticeably brighter. So this is like approximately 50 millimeters away from the cells. We're now reading 5.17 volts and 0.6 microamps. I'll now try putting them closer to approximately 10 millimeters with the same value. I'm now going to try 100 millimeters away. Nah. So I think the sweet spot is definitely 50 millimeters in front of the cell. So that got me thinking, if it works well at close range, why don't I do it at standard distance, i.e. fridge to the table, which is around 6 feet, or probably closer to 190 centimeters or 1900 millimeters, which is pretty good, I'd say. So I tried that and then this happened. Right, so this is a test from a distance with the suspended medium 50 millimeters in front of the solar cells. So there we go. That is. These are at a lot of capacity. Don't know if that's much more luminescent, but I will proceed to use the concave lens to make sure laser light hits all of the suspended medium. That is now completely covering the medium. See if that has any effect on the light. Which actually, in hindsight, is not a bad thing, because although I hit a bit of a speed bump, and then another speed bump, and then crashed the car, apart from that, I actually did make a new discovery. Now, what I can do with this information is I can either make a matrix of progressively more luminous sheets in front of the cells, or I can make a kind of prism around the cells, combining the luminous material with mirrors, so that any lost light, because if I show you in this video here, there's lots of excess light like surrounding the cells. So my thought is, what if I set up an array of mirrors and luminous mediums around the cells to increase the light and recapture any lost light? I think that might be a viable next prototype. But that is a thought for another day, because I'm going to temporarily stop this series just so I can kind of give you a break from the same old thing, and because I am very low on funds to continue this series at the minute. But this series will definitely return at some point in the future, probably near the end of this year, if not the beginning of next year, with a fully completed 5th revision. This will be prototype with the prism idea implemented, if not a new idea that I've come up with. So that is all for this video. Thank you for watching, and I'll see you in the next one.